Hi Vicky, I wanted to make this video to share mainly the experiments that I have been doing with the model. But first, let me go through the process of a bit of the work I've been doing this couple of months, and it's about generating instance more automatic. Yes, so let me first go through that process, and in a second video, I will show you the results of the experiments. That will be our agenda for this couple of videos. Let's go into the business. So we have the refueling facility expansion problem. A quick reminding of the problem. We want to locate service stations in a network and define the capacity of the stations. And to do that, vehicles will be traveling through that network, and they will be traveling through a concept we define as paths. Yes, and a path is defined by an origin and a destination. And on the path, vehicles can find stations where they can refuel. And these stations can be existing stations from suppliers, existing stations that I own as a company, or potential stations that I just put there to say, hey, will it make sense to locate a station? Will be a financial benefit if I put the stations there like that. That's the problem. Okay, how are we generating the data to solve the model and test the algorithms we want to implement? So before that, let me tell you, okay, that a path is a little bit more complex than what we see in a path. Not necessarily, the station is not technically along the path. To go to a station, we define that there is a deviation distance. So the magic of the procedure to generate the data is being able to compute all these distances. Yes, the distance between the origin of the path and the diversion point. This is the name of this point to go to this station. What is the diversion distance of each station depending on the path and all of these parameters. Okay, so how to generate the path? So basically, I generating the scenarios with points in Australia, basically in Victoria, New South Wales, and Queensland. So I have these 49 points located around the states, and I have many points in the capitals of each state, for example, here in Melbourne, Sydney, and Brisbane, to also simulate small arcs that I'm going to be defining. So I define all that points, and I define all the existing arcs of that 49 points, which are like 49 times 48, which is 2,352. So these are all the arcs that are defined by these points, that all the possible connections. Then I have the stations that are located in Australia. So I have all this combination of stations. So the first step after defining these things is defining, okay, which stations are along each arc, so I can compute the distances. So that's what I do. I define the stations of each arc. This line specifically here is representing an arc. So I calculate which are the closest station to each arc, and I calculate the different distance around that. Then, when I have defined all the features of an arc, I define what I call path. And a path is a collection of arcs. So basically, yes, I randomly start to take consecutive arcs until I am able to calculate a path which length is according to a certain parameter I want to define. In this case, a simple example, I want to create a path of 2,000 kilometers. So I say 1,000 kilometers arc, then I pick this are 500 kilometers, and then I pick this are 700 kilometers. Here are 2,200 kilometers, so the path is done, ready. The path is completed. But also something important is that these black points here, the model won't know about that. Like, they will be implicit for the model because the information about the path in the model is given by something more similar to this, like an initial point, the yellow point, an end point, the green point, and the stations. Yes, and I will have to calculate. And from the arcs, we know this information, this. And when I am making the path, I am calculating like that distance when I connect the arcs. So I think this example is very illustrative. Something like this is read by the model. For example, path 1 have these small segments. look, all these small segments. So I have the origin is a node that is called power reserve, and every node with an ST is because it's an station. So in fact, in the origin node, there is an station. So the distance between this segment is 0. But then after power reserves come monads station. After monads comes core station, and so on and so on and so on until I finish the endpoint, and the endpoint is power reserve. And look, this is something special. This path ends where it starts in power reserves, and it doesn't happen. It can happen. So yeah, that's happened. This is an example of another path. I define the paths of the model, but then to be able to calculate all the data that the model needs in order to run, I also need to provide some other inputs. So another important input is which type of vehicles I'm gonna have in the network. So I define this, in this case, a type of vehicles and are the characteristics of the vehicles. Also, I need to say which are the range of discounts of the suppliers. In this case, I have two suppliers, BP and Viva, and I have two ranges of discounts. In one range, I don't have any discount, but in the other, I have some discount. You won't see here the limits of the discount because that's calculated in another process. And also to generate an instance, I define what I told you before. We define the length of the path. For example, 10,000 kilometers. Before I was creating a toy instance of 2,000 kilometers. I define how many instances I want to create, how many paths, sorry. So 5,000 paths, okay, let's create 5,000 paths. And then I define what is the total refueling quantity in the network. And this total refueling quantity will be important to define how many vehicles of each type are gonna travel in each of the paths. So I have a logic that randomly I assign type of vehicles to paths such that at the end the vehicles consume 100 million liters, which is this parameter I define here. After doing this, I will have the set of tables that will fit the model. Yes, and let me call this table the generator tables. Yes. So basically, generator tables are big tables, and from these big tables, I will make children tables. What I mean is the following. So I have a generator scenario, which is the set of tables I showed you before, but there is something I cannot change from this table, and it's the length of the path. So from this set of tables, we have different paths, and the length is something that is fixed. So, but I have also other types of features in each scenario, which is, okay, how many paths, how many type of vehicles, how many on station, how many candidate location, how many suppliers. All of this information, like all of these, are considered factors that directly impact the size of the model. So to create many instances, I'm going to be playing with all these factors. So I will take this generator path, this generator scenario, sorry, and I will create a scenario that has, for example, 10 paths, 100 paths, 500 paths, 1,000 paths, 5,000 paths. And I will define different levels for each of these factors, so I can have hundreds of thousands of scenarios to test the model. So basically, that's what is done. And this is a table that tells me, okay, this scenario with these characteristics with two type of vehicles, 10 paths, 30 on a station, 20 candidate locations, 2 suppliers, which tables reads. So which table? Okay, the table of nodes, the table of suppliers. So I define a code for each of the tables that are associated to this scenario. And this procedure of creating the children tables of a parent scenario of our generator scenario is implemented in Python in a Python script. And something important that this procedure has is that there are some parameters that I calculate because, for example, if I have 5,000 paths and I get just 5 paths, what will happen? That the consumption in the network will reduce. So there are some parameters in the model that depends on the size. Yes, for example, which parameters? The minimum quantity that I can buy to a supplier. If I define the minimum quantity with 5,000 pads, it should be different if it's with 5 pads. So in order to calculate that parameters, I run multiple small optimization problems, yes, that help me to compute in the network, in the small networks, what will be the consumption of fuel, and so I can estimate the parameters and guarantee feasible solutions. So that is done, and that's how works the process of generating a scenario. So we have a lot of tables. In the next video, I will show you the experiments and how the model is running in those scenarios. So thanks for watching.